Did you know that you could be older than your twin? Like years older? According to Einstein's theory of special relativity, it's possible because time can tick faster or slower depending on how you're moving. What? Yeah, we'll get back to that. But first we're gonna learn all of special relativity. Don't worry, there are only two postulates. One is that the laws of physics are the same for everyone's perspective, or frame of reference, while in uniform motion. So that means that on a plane cruising at 800 kilometers per hour, an object you drop will fall straight down, just as it would if you're stationary on the runway. Same physics in those two frames, otherwise plane rides would get real weird. The crazy implication of this postulate is that there's no experiment you could do to tell that you're moving, even at 800 kilometers per hour, even at 1,000,000 kilometers per hour, because you can only tell you're moving relative to something else, like the clouds outside your window. The second postulate is that the vacuum speed of light is the same for all observers, 300,000 kilometers per second. Let's just pause on that for a sec. Do you know how freaky this is? It means that if you're flying toward me in a spaceship going close to the speed of light and you shine a laser at me, you'll still measure that light to be going at 300,000 kilometers per second. And I'll measure the light to be going at 300,000 kilometers per second as well. So those are the only two postulates of special relativity. The speed of light is a constant, and the laws of physics are the same in every inertial reference frame. Inertial meaning not moving or moving at a constant velocity. Basically, you're not accelerating. And when you do accelerate, like when you experience turbulence or during takeoff when you're pushed back into your seat, you can tell you're moving and special relativity no longer applies. So it's from just these two postulates that we derive an entire physical theory and get crazy things like length contraction and time dilation and other weird quirks of physics that are real. One such quirk is that time can tick at different rates depending on how you're moving. We call this time dilation. It's weird, but it's real. Why does it happen? Consider two frames. One is you stationary on Earth, and one is your twin zooming by in a rocket. You have identical clocks. Let's look at yours first. Each time light makes a round trip in your clock, you count by 1. Your twin will measure the same rate on her own clock. Now, things get weird when you watch her clock. Because of her sideways motion, you see that her light has to travel a longer distance for one tick. And since the speed of light is the same for all observers, her round trip ticks must take more time. So time actually ticks slower on her moving rocket according to you, stationary on Earth. And this is a real phenomenon. It's not some weird mind trick. We don't usually notice this though, because time dilation is quite insignificant until you're moving close to